Okay, in this video, we start to take a look at what are polar equations and polar coordinates and just basically polar mathematics. Now, what is polar? Polar is really used when we're talking about things that are circular or spirally or things like that, things that don't work well on a function, on an XY plane, we often do in polar. Now, you've been working for a really long time in what are called rectangular coordinates, and the reason that you've been working in what are called rectangular coordinates is if I were to draw a graph and I were to plot a point on that graph, the coordinate of this point, the coordinates of this point are x, y, because you've moved horizontally x amount and vertically y amount, and then basically you can go horizontal and vertically this way, horizontally and vertically this way, and you've created a rectangle right here. Polar, you don't actually get to a point by going left and up or horizontally and vertically. What you do with polar is you maintain a certain distance from the origin and then you measure your angular distance from the positive x-axis. So basically what I'm talking about here is that polar coordinates are just another way to locate a point on the xy plane. Instead of moving horizontally and vertically, we start at a given location on the x-axis, call that r, and then move a certain number of radians theta from that point, maintaining a constant distance from the origin. Okay? Now, when we do that, we create polar coordinates of r and theta. R being your distance from the origin, and theta being your angular distance from the positive x-axis. Now, what does that mean when you have negative r and theta plus pi? Well, what that means is if we go back to this other page here, if we have something on the xy axis, and I were wanted to say plot the point 4 comma pi over 4, this always has to be in radians, by the way, that means I go out 4 units from the origin, and then follow a circular path pi over 4 radians away, which is 45 degrees, which is going to put me right here. So this distance is still 4, and this angle is pi over 4 radians. Okay, so that's 4 pi over 4. Well, I could also plot that by calling it negative 4, 5 pi over 4. And the reason for that is what it's telling you is it's saying, okay, go 4 out, so be 4 units away from the origin, but have an angle of 5 pi over 4, which is down here. So this point would be 4 5 pi over 4. But if we go in exactly the opposite direction, this right here, if I could get the pen to work, there we go, is the point negative 4 5 pi over 4. So whenever you have a negative, that just means you go 180 degrees in the opposite direction, okay? Let's see. Also notice r theta and negative r theta are endpoints of a straight line whose midpoint is the origin. That's what we just looked at over here. Here's 4 5 pi over 4 and negative 4 5 pi over 4. And they are on the same line. Alright, so now the big point here and the piece that we use a lot are conversions. So if I have a point, if I take any point I want, and let's say why can't I get to my pens? There we go. And I were to plot that point right here, little happy face, I can get to that point by either going over x and up y, or I can get to that point by going out from the origin r units and theta units, theta angular units from the positive x-axis. So I can get to this point by going over and up, or out and around. Over and up would be xy, out and around would be r theta. Well, the thing that we just created is a right triangle. And within this right triangle, a couple formulas come to mind. And you can write these down or just deal with the ones that we have over here. This is just basically how we create them. This is a right triangle, so one thing we can have is x squared plus y squared equals r squared, because this is a Pythagorean theorem. Well, that makes a lot of sense. Another thing we can have is that tan theta would be y over x for SOHCAHTOA. Well, tan theta is y over x, no big deal. So what we've done here is we have two nice equations where r and theta are basically by themselves, and x and y are also joined on another side. So these are great equations to use if you want to go from rectangular to polar. So if you have x and y and you want to get into terms of r, you could use this. If you have x and y and you want to find theta, use that. Now, tan theta isn't the only SOHCAHTOA we can use. We can also say sine theta would be y over r. In other words, r sine theta equals y. Along the same lines, cos theta equals x over r. So r cos theta equals x. That's where these two equations come from. X equals r cos theta, y equals r sine theta. Long story short, though, you need to have these memorized. And if you have a hard time memorizing them, memorize this so that you know how to get them. These are extremely important. So this box right here, I cannot emphasize enough. Make sure you get those memorized as soon as possible. All right, so coming on down here, let's start talking about plotting points and converting points. If you want to plot the following polar points in the xy plane, if I know these are polar, I know that this is r and that's theta. So I need to go 5 units from the origin, 0 degrees from the positive x-axis. So 5 units from the origin, 0 degrees away, that would be the point. 5, 0 in polar, and actually in this case, it's also 5, 0 in rectangular coordinates. 3 pi over 4, so 3 units out from the origin, pi over 4 units around, which is 45 degrees, puts me right here. -2, 3 pi over 4, so 2 units away from the origin. 3 pi over 4 puts me here, but then I have to go in exactly the opposite direction. So there you go. Another way to plot this, if you want, you could start at -2 on the x-axis and then actually go 3 pi over 4 away from that to get you to the same place. Okay. And then last but not least, r equals 0, so 0 units from the origin. Theta equals pi over 9. Well, it doesn't matter what theta is because if I have an r of 0, I'm always at the origin. So 0 comma anything you want is always the origin. So 0, 0 in rectangular is 0 anything in polar. All right. Now conversions. Convert the following polar coordinates into rectangular coordinates. So we're going to use that box up here. We're going to use this guy. So if this is polar, this is r, this is theta. X is r cos theta. Y is r sine theta. So if x is r cos theta and r is r sine theta, y is r sine theta, I just plug everything in. X would be 6 cos pi over 6. So that's going to be 6 times radical 3 over 2, which is going to be 3 root 3. And then y would be 6 sine pi over 6, which is 6 times a half, which is 3. So in rectangular coordinates, this is going to be 3 root 3, comma 3. That's it. That's all you have to do. Same thing over here. X equals r, and even though r is negative, I'm still going to use r cos theta, so r cos 3 pi over 4, which is -8 times negative root 2 over 2, which is going to be positive 4 root 2. And y is going to be -8 sine 3 pi over 4, which is -8 times positive root 2 over 2, which is negative 4 root 2. So this is now 4 root 2, negative 4 root 2 in rectangular. And then last but not least is really funky one over here. So for this one, we have, let's see, we have x equals 10 times, whoa, wait, arctan 3/4. I really don't want to write tan 10 cosine arctan. Ugh. So let's draw this over here. Arctan 3/4 would be a tangent of 3 over 4, which makes my hypotenuse 5. So 10 times the cosine of theta, this being theta, would be 10 times 4/5. Now wait, how did I know what that was in the first quadrant? Well, arctan always implies that your angle is in either quadrant 4 or quadrant 1. And since it was positive, I know it's in quadrant 1. So 10 times 4/5 is going to be 40/5, which is 8. And then y would be 10 times the sine of theta, which is 10 times 3/5, or 6. Hang on a second, I'm just going to pause. Now, when we switch from rectangular to coordinates to polar coordinates, sometimes it gets a little bit more complicated, which you'll see. So if I have rectangular coordinates of x and y are 3 and 3, the best formula to use is x squared plus y squared equals r squared to get my radius. So I'd have 3 squared plus 3 squared equals r squared. And r is going to be 3 root 2, because I'd have the square root of 18, which is 3 root 2. And technically, you might be thinking, well, technically, can't r be plus or minus 3 root 2? Yes, it absolutely can. And we'll talk about what to do with that in a second. Then tan theta equals y over x. So theta is pi over 4, because tan theta equals 1. And then you also might be thinking, wait a minute, could tan theta be pi over 4, or can it also be like 5 pi over 4? Yes, it absolutely can. But if you use the primary value for tangent and the primary value for r, we end up with 3 root 2 comma pi over 4. Then, to make sure you have the right answer, you want to make sure you end up in the right quadrant. So if I have a positive radius and a theta that's in quadrant 1, is this point in quadrant 1? Yes, it is. So you need to just check when you're done to make sure you end up in the right quadrant. If you wanted to use the negative value, which I don't suggest, but you can, you would make it negative 3 root 2, and then you'd use 5 pi over 4. Because 5 pi over 4 puts you in quadrant 3, but the negative radius backs you up into quadrant 1 because you have to go into the opposite direction. So technically these are equivalent, but we probably wouldn't use that one because it's negatives and we just don't want to go there. All right, so if we jump to the next one, if I have x squared plus y squared equals r squared here, I'd have negative 3 squared plus root 3 squared equals r squared, and that's going to be 12. So r is going to be, let's see, 2 root 3. Again, you can do plus or minus, but I say always go with positive r. There's no reason to have a negative r. And then tan theta equals radical 3 over negative 3. And let's see, if tan theta equals root 3 over negative 3, the inverse tan of negative root 3 over 3, well, the reference angle would be 60 degrees, which is pi over 6. This would be in quadrant 2. So pi over 6 in quadrant 2 is 5 pi over 6. So in polar, this is going to be 2 root 3, 5 pi over 6. And then last but not least, this one, 0, negative 5. If I do x squared plus y squared equals r squared, I'm going to get r equals 5. And if we do tan theta equals y over x, I'm going to get theta equals, well, tan theta equals undefined. So tangent's undefined at pi over 2 and 3 pi over 2. If I want this to be on the negative y-axis, I want to use 3 pi over 2. So 5, 3 pi over 2 for that one. All right. So thus ends page 1 of our polar note.